بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله. Hi grade 8 in all over the state. Hi dear كبيدة students. I hope that you are all fine, you and your families. I would like to thank كبيدة International School for giving us this opportunity to share our final revision with other English media schools. Let's start our revision. Question 1. Put true or false. Please read the instructions of the exam very well and read the question carefully and do whatever he wants you to do. If he asks you to put true or false, put true or false. If he asks you to put cross, tick or cross, please put tick or cross. Number 1, 3/5 is a decimal rational number. We all know that a decimal rational number, if I want to know if the fraction is a decimal rational number or not, I need to look to the denominator of the fraction. If the denominator is 2, 5, 10, or one of their powers, then the decimal representation will be definitely a decimal rational number. And hence, the denominator is 5, so my answer is true. It is a decimal rational number. Number 2, the equivalence of 4 for the base 3 is equal 4. If I have a number and the base is 3, I want the equivalent. If 3 raised to power 4, what is the equivalent? What is the number? But here he wrote 4 to power 3, where it's clear that the base is, he wrote the base is 3, but he wrote the base 4. And this statement is completely false. Be careful with such a question. Number 3, the irrational numbers can be written in A over B form. This is also completely false because we know that the rational numbers are the number can be written in A over B form. Number 4, the mode is the most frequented observation. This is in the statistics. The mode is the number that is repeated the most. Frequented means repeated. So this is completely true. We mean that the mode is the number which is repeated the most. So this is true. Number 5, the expression x squared plus 4x y plus y squared is a perfect square. If I want to know if any expression, if it is a perfect square or not, any second degree expression, then I need to look at the first and last terms. If first and last terms are perfect squares, then and this is the first condition, the first and last should be perfect squares, and the middle term should be 2 times square root of first times square root of last. This is the first condition is happening here, but the second is not. This is 4 times the square root of first times the square root of second, and this is completely false. Number 6, the shortest line segment drawn from a point outside a line is the perpendicular one, and this is completely true. This is one of the inequalities theorems. Number 7, the number 1.212112111 is a recurring rational number. Recurring means repeating, and it's clear that this number is not repeating the proper way. It should be the same way of repetition, but this is, the one is written 1 time here, written 2 times, and then written 3 times. So this isn't a recurring rational number, so the answer here is false. Number 8, if f is a function from I to I, defined by the rule f of x equal x squared, then the application is 1 to 1. If I want to know a question like this, I need to draw a small arrow diagram aside to examine it if it is 1 to 1 or not. We all know that integer numbers are negative numbers and positive numbers plus the 0, and so if I want to know something like this, I need to put negative numbers or positive numbers in the same diagram. So negative 1, 0, 1, negative 1, 0, and 1. So he said that the function is x squared, so I need to square the element of the x and see what's the answer. So negative 1 is negative 1 times negative 1 equals 1. So the negative 1 is mapped to 1. 0 times 0, or 0 squared, is 0. And the 1 times 1 is also 1. It's clear here that the negative 1 and the 1 both mapped to 1. So this isn't a one-to-one function. And the answer is false. The point is, on the first quarter, if x is greater than 0 and y is greater than 0. We all know that if x greater than 0, that means it's positive number. And if y is a greater than 0, it's also a positive number. So it is actually in the first quarter, and this is true. Also, if you want to know the answer here, if you draw a small Cartesian plane aside, and that will help you to know the quarter of the point. Number 10, all medians of a triangle meet at one point. This is the fourth theorem of the medians, of the transversals and medians, and this is completely true. We all know that. All medians of a triangle meet at one point, and we call this point the centroid. Number 11, from the equation x squared minus x minus 6 equals 0, the product of the two roots is equal negative 6. We all know that the product of the two roots is actually the free term, or the last term. So the free term here is negative 6, and this is completely true. That is, the product is negative 6. Please put the sign in consideration. The answer should be with its sign, okay? So my answer here is true. Number 12, the perpendicular bisector of any chord passing through the center, or passes through the center of the circle, and this is completely true. Number 13, okay, 12 over 15 is not a decimal rational number. This one is just like the one before, but there's a small or a slight difference. The number before was a number in its simplest form. That's why I directly tested if it is a decimal rational number or not. But this one is not in its lowest term. So I need to simplify it or cancel it first. And we do that by multiplying both numerator and denominator by 3. The condition here is that both numbers should be divisible by the same number. So it's clear that 12 and 15 can be divided by 3, and the answer will be definitely 3 over 5. 4 over 5, sorry. 4 over 5. Hence, the denominator is 5. So the number is a decimal rational number, and here my statement is false. Number 14, the hypotenuse is the longest side in a right angle triangle. We know that in a right angle triangle, there is a 90 degrees angle, which is the right angle one, the right angle. Hence, the sum of the three angles is 180. If one of the three is 90, then the two other angles will be definitely 90. So for sure, the right angle is the bigger angle, and definitely the opposite side, which is the hypotenuse, will be definitely the longest side. So this statement is completely true. Number 15, log 1 for the base x equal 0. That means what? The power here is 0. If I raised the x to power 0, that will definitely give me the 1 So this statement is completely true. Number 16, the application is a special relation. This is true. If I brought an application, all the elements of the domain are connected to only one element of the domain, then this relation is an application. Number 17, negative 3 plus 3 equals 0 according to identity element of addition. And this is, I need to look carefully because students usually mix between additive inverse and identity element. Here, I added negative 3 to positive 3. So I added a number plus its additive inverse, which means the property right here is the additive inverse property. So the statement here is completely false. Number 18, equal chords have the same distance from the center of the circle, and this is also correct. The second degree equation, x squared minus 16 equals 0, has no solution in real numbers. I will need to explain in the whiteboard. If I have x squared minus 16 equals 0, if I want to find the values of x, I need to factorize first. So it is x minus 4 and x plus 4. So the solution set here is 4 and negative 4 after taking them to the other side. Either this one equals 0 or this one equals 0. It's clear that there is a solution set right here, and it belongs to real numbers. But there is another case. If it was like x squared plus 16 equals 0, then to solve this, I need to take the negative 16, the positive 16, sorry, to the other side, and then it will be x squared equal negative 16. To find the values of x, I need to take the square root for both sides, and then here is the problem. On the real numbers, I don't have a value for the square root of negative numbers. That's why if it is x here plus x squared plus a positive number, plus يعني, then it has no solution in real numbers. But if it is negative, then, and if I took this to the other side, then it's positive 16, and after taking square root, it's also positive 4 and negative 4. So you need to differentiate between those two cases. The first one has a solution in real numbers, and the other one has no solution in real numbers. So number 19 statement is false. The last one, 1 and 1 are the coordinates of the origin point. This is completely false. We all know that the coordinates of the origin point is 0 and 0. Question 2. Complete the following. Read questions carefully. The application is bijective. Bijective has another name, one-to-one corresponding. So you need to know both of them. So if the application is bijective, one-to-one corresponding, if it is dash and dash. If it is onto and one-to-one, surjective and injective at the same time. Number 2, actually it is dash, is a part of area of the circle included between an arc and 2 radii. In this one I have two, I need the board to explain it. I have 2 parts of the area of the circle, and usually students mixed between them. Here is 2 circles to differentiate between them. If I have, this is the arc, and those are the 2 radii. it's clear that this is the sector. And if I have an arc and a chord, so this part of the circle, the circle's area, called the segment. So if he said that part of the area of the circle included between an arc and 2 radii, then it's a sector. And if he said that the part of the area of the circle included between an arc and a chord, then it's a segment. So here it is the sector. Number 3, the point 5 and 0 lies on the x-axis. We all know that if the y-coordinate is equal to 0, then the point lies on the x. And if the y-coordinate, the x-coordinate is equal to 0, then the point is definitely lies on the y-axis. So number 4, Q intersection Q star. We all know that intersection means the common elements. Are there common elements between rational and irrational numbers? Is there a number can be rational and irrational at the same time? Of course, the answer not. So the answer here is phi, and we mean by phi is the empty set without elements. Number 5, if f of x is equal x squared minus 1, then f of 3 equal, I need the board to show you how to do this. The mapping rule is x squared minus 1. And in the x, he wants the f of x, the f of 3, sorry. So all I need to do is to take the x, put the 3 instead, or substitute by the 3. So it will be 3 squared minus 1, which equals 9 minus 1, which equals 8. So f of 3 is equal 8. We call it the image of 3. Number 6, x to power 0 equal 1. We passed through this before. Any number raised to power 0 is equal 1. Number 7, the length of any side of a triangle is greater than. If I have a triangle with 3 sides, he wants the relation between those 3 sides. One side is definitely greater than the difference between the 2 other sides, and this third side will be definitely less than the sum of the 2 other sides. Number 8, from the data 45472, the mode is, we said that the mode is the most frequented number. It's clear that the 4 is repeated 2 times, so it is our mode. Number 9, if x plus 3 equal 5, then x equal 2 according to what property? You need to look carefully. What's happened? It was x plus 3 and 5. Actually, the 5 is 3 plus 2. So what I did is I canceled 3 from both sides, and what remains is equal, x equal 2. So it's clear that I canceled, and we know that the property of canceling, we call it brevity property. In number 10, the relation between centers of intervals and frequencies is a graphical representation called the frequency polygon. We all know that the frequency polygon is actually a point on the plane between the center of the interval with the frequency. So we call it frequency polygon. In a cyclic quadrilateral, each 2 opposite, here we need to encircle or choose the correct answer. In a cyclic quadrilateral, each 2 opposite angles are. We all know that each 2 opposite angles are supplementary. What do we mean by supplementary? Supplementary means the sum is equal to 180 degrees. Number 2, there is something missing here. It's 2.13. The recurring sign is above the 3 only. And 2.13, the recurring sign is above the 1 and 3. I will write that on the board so we can differentiate between them and we can compare properly. So it's 2.13 recurring and 2.13, the recurring sign is over both of them. We mean by this 2.1333 goes to infinity, and this one is 2.131313 also goes to infinity. It's clear that this number is greater, hence I will compare between them one by one. So answer B is the correct answer, greater than. The solution set of equation x squared minus 25 equals 0 is the answer D. We passed through this. If I want to find the solution set, then I need to factorize it first, and then after either an or, you will find the values of x. And actually, there are two values of the x, and they are 5 and negative 5. So answer D is the correct one because it's 5 and negative 5. If the arithmetic mean of the values 7, 8, 2, x and 3 is 6, then x equal, here I have a missing one of the values. You want me to find this missing one? This is very easy. I can find my arithmetic mean first I have the arithmetic mean and I have the number of values. I can find the sum of the values, and then I can, second step is to add the given ones and then find the difference between them. So it is 6 times, to find the sum, actually the sum equal the arithmetic mean times the number of observations, and that equals, he said that the arithmetic mean is 6 times the number of observations is 5, so it's 30. And after adding those values, it's 20. So 30 minus 20, definitely 10. So my answer here is 10. The next one is the centroid divide each median from the vertex side into the ratio of dash. There are two questions. Sometimes he gave you two different questions in this case. He asks sometimes from the vertex side and sometimes from the side of the side. If he, be careful with this please, if he said from the vertex side, then it's 2 to 1. The bigger side is from the vertex side and the smaller is from the side of the side. So be careful, read it carefully. If it is from the vertex side, then it's 2 to 1. And if there's from the side of the side, then it's 1 to 2. Number 6, the range is a subset of dash. We all know that the range is a subset of the co-domain of the relation. Number 7, 2 times x plus 3. We all know that if there is no sign and there is a bracket, it's multiplication operation. So it's 2 times x plus 3 equals 2x plus 6, represented by the property of. He wants the property here. I need to look carefully. It was 2x, 2 times x, and 2 times 3 equals 6. So what happened that I multiplied the 2 times x and the 2 times 3, so I distributed the multiplication over the addition. So this is distributive property. Put the suitable sign. I have I and Q. What is the relation between I and Q? We all know that I are the integer numbers, Q are the rational numbers, and I are the positive numbers, negative numbers, and the 0. Q are the negatives, positives, 0, plus the decimals and fractions. That means the set I is a subset of Q, so I choose B, and please put in consideration to not put element of, because we use element of if it is an element part of a set. Okay. Number 9, the rational number is dash. I have 4 options. One of them is a rational number. Let's review that quickly. We all know that by is 22/7, and it's a non-terminating, not repeating number. And also, the number square root of 13 is a number under square root, and it's not a perfect square. So the result of finding its square root is a non-terminating, not repeating number. The C is 1, 2, 1, 1. It's actually, they are trying to make it as if it is a recurring, but it's clear that it's not recurring. The 1 is repeated twice here and 3 times there. It's clear that 3.7 recurring is a rational number because it's a recurring number, and we know that the recurring numbers can be written in A/B form, so it is rational numbers. Okay, let's go to find the values of the following. Here I have 7 plus -5, have 2 numbers with 2 different signs. Then I will subtract and give the answer the sign of the bigger. So 7 plus is actually 2, positive 2. -7, -3, I have 2 numbers with 2 same signs. Then I will add and give the answer the common sign. So 3 plus 7, 10, and they are both negative, so -10. Whenever you want to multiply a recurring number, I'll do that on the board. If it is 10 times 3.7 recurring, we all know that 3.7 recurring, it's actually 3.777, and that goes to infinity. When you multiply times 10, then you will remove the decimal 1 place to the right side, so it will be 337.7 recurring. And that's another recurring number. If it is 6.63 recurring times 100, then move the decimal 2 places, and I have a small tip. If it is the number of places that you will move the decimal place is according to the number of zeros. If the 10, 1 0, 1 place, 100, 2 places, because it has 2 zeros. Okay, when multiplying a number, dividing a number by a fraction, then this is division of fractions. So we need to change this division into multiplication. We don't do this just like that. If I want to change the division into multiplication, then I need to switch the second fraction, and we switch it means multiplying by the reciprocal or the multiplicative inverse, and then after switching it, you multiply the numerator times numerator and denominator times denominator, and if there is a way to cancel, you cancel. 2/4 in A/B form. I have a mixed number. I want to write it in A/B form. That means I need to change it into an improper fraction by multiplying the whole number times the denominator plus the numerator over the same denominator. So 2 times 4, 8, plus 3, 11. So it's 11/4. Put the symbols x and y in a statement to represent the commutative property of addition. We all know that the commutative property means that the order in the operation of addition, the order is not important. The order doesn't matter. So that means you can put the x first or the y first. That will give you the same answer. Let me give you a numeric number. If I have 3 plus 5, it's 8. What if it is 5 plus 3? It's also 8. So it doesn't matter which is first and which is second. So when using x and y, I will write x plus y will be equal to y plus x. Complete the following. The set of irrational numbers is denoted by the symbol Q star. B. 2 over 3 plus dash is equal 0 according to dash property. How am I going to know this? I talked about the additive inverse and multiplicative inverse before. If I want to know if it is multiplication or addition, first I have plus here. That means we're talking about multiplicative inverse property. That means if I want to get rid of this number and make it 0, then that means I need to add its additive inverse. So 2 over 3 plus negative 2 over 3, that makes it 0. And this is according to additive inverse property. If I have N, R, Q, I are sets of natural numbers, real numbers, rational numbers, and integers, respectively, then we know that the smallest one is the natural numbers, which is the positive numbers. It is actually a subset of integers, and the integers are subset of Q, which is rational numbers, and they are all subsets of the real numbers. Evaluate the following. X cubed times x to power 4. If I have multiplication of numbers with powers, and I have bases are the same, but powers are different, the answer will be putting the same base with adding the powers up. So it will be x to power 3 plus 4, which equals x to power 7. Okay, and for sure this one is division. We know that the opposite of multiplication is division. That means if I added the powers here, then definitely I will subtract the power there. So it is 5 to power 9 minus 3, and that will be equal to 5 to power 6. And we don't use this if the bases are not the same. Be careful with this. The bases should be the same. Okay, in number 3, it's y squared all raised to power negative 3. It's clear that there is one number raised to 2 power or raised twice to powers. And what I should do here is to multiply the powers. So it is y to power 2 times negative 3, which equals y to power negative 6. Okay, there's one small tip. If I have a negative power, then I should write it as a positive power. It's very important. I have y to power 6. Don't leave it like this. You just switch it, write it as 1 over y to power 6. Find its positive power. Change the negative power into positive power. Find the values of the following. This is very important. If I have log a for the base a, the equivalent and the base are equal. That means if I raise the power, the base to what power will give me the same base? And this is the one for sure. A to power 1 equals a. Here I have log 1000. It's clear here that I don't have a base. And we all know that if he did not write a base, that means it's base 10. So what is the power when I raise 10 to? It will give me 1000. How many times should I multiply the 10 times itself to give me 1000? It's definitely according to the number of zeros. If I have 3 zeros, that means it is 10 to power 3. If 4, then power 4. If log 6.31 equal 0.8, then log 631 is equal. If I want to find the logarithm, I have to look to the numbers here and count the number of whole digits Here I have 3 whole digits, and then subtract 1, that will give me 2. If I have decimal numbers, the decimal number means the whole number is equal 0. So if it is a decimal number, I need to use the board. If I have, so say it's 0.0631, you want the log of this number. I have, after the decimal, 1 0, add 1, then it's 2. Then the signal number will be negative 2.8. Why negative? Because this number is decimal. We all know that the logarithms of negative numbers, of decimals, are always negatives. Number 4. Okay, that's another question. Complete the following. If f of x is a function, if f is a function from x to y, defined by the arrow diagram. Okay. Okay. First, he wants that domain. We know that the first set where the arrows are coming out from is the domain. So it's 1, 2, 3. Please, when this is, and I call questions on pocket, it's marks on pockets. Everything is just given, but there are small tips. Don't forget to write the set between the set brackets, and don't forget to put the commas between an element and the other. So he wants the domain. It's all the elements of the first set. And he also wants the co-domain, which is all the elements of the other one, and we call the codomain where the arrows coming into, which is the 2, 4, 6, and 8. He also wants the range. The range is the set of images. After the image, the 1 is the image of 2, the 2 image of 1, and the 4 image of 2. The 3 is the image of 6 image of 3. So we put the images together in one set, and also hence I said set. Then please don't forget the braces of the set. F of 1, that means we call this, F of 1 means the image of 1. What is the image of 1? M, the image is the number that is in the codomain and connected with the 1. So the 1 is connected with 2, so the image of 1 is 2. The mapping rule. If I want to know what's the mapping rule, I need to look at the function carefully and look why is this number is related to this number. 1 is related to 2, 2 related to 4. It's clear that the number is related to its double, so it's 2x. The mapping rule here is 2x. Is it an onto function? To say that a function is an onto function, then all the elements of the codomain should be connected. And that means, we say it in other words, the range is equal to the codomain, and it's clear that here the range is not equal to the codomain. The range is 2, 4, 6, and the codomain is 2, 4, 6, and 8, so it's not an onto function because the range doesn't equal the codomain. This is very important. You have to say this is exactly. The range doesn't equal to the codomain. Is the inverse function exist? Of course no, because we know that the inverse function exists if it is bijective. What do I mean by bijective? If the function is bijective, then it is 1-to-1 and onto. But here it's not 1-to-1, so it's not bijective, so the inverse function doesn't exist. Here I have 3 functions or relations. They are not functions, they are relations. And he wants me to tell the type or if it is function or not. I always prefer, before writing the type, that you need to examine it if it is a function or not, and then examine the type. If I want to know if it is a function or not, I have to look at the domain. If all elements of the domain should be connected, and it should be connected to only one element. So that means all of them are connected, and then each one is connected to one. There's no other one mapped to two. So this one is a function, but if I want to know the type, I need to look at the co-domain. Here, it's clear that each one is connected to only one, but the last one is not connected. So this is not one onto, but it is one-to-one. So here, it is one-to-one, but not onto. The second one, it's clear that 3 is not connected, and 3 is in the domain, so this is not a function. Hence, it is not a function, then it has no one type of functions. It's not a function at all. The third one, it's clear that it's a function because all elements are mapped, but its type, it's clear that it's onto because all elements are connected, but it's not one-to-one because 5 is an image of 2 elements, or it is connected to 2 elements, so it's not one-to-one, but it is onto. Okay. Now, statistics, the last chapter of the book. If I have this data, 270710779, he wants me to find the range. In statistics, we know that the range is the highest number of the data minus the smallest. The highest number here, it's clear, it's the 10, and the smallest is the 0. So it's 10 minus 0, which equals 10. The biggest minus the smallest. And we talk about the mode many times. The mode is the most frequented number or the most repeated number. It's clear that the 7 is repeated 3 times. So our mode is the 7. The arithmetic mean. The arithmetic mean is the sum of data or the sum of observations over the number of observations. So, yes, sum of data over the number of data. I added them up, and they are 7 observations. So it's 42 divide 7, 6. And we usually, the arithmetic mean is the number in the middle of the data. Okay. Here I have a table, and this table, I need you to look carefully. It is 0 and less than 10. We call this intervals. We divide my data into intervals, and we took the frequencies or the number of the repetition of the data in this interval. We call this table the frequency distribution table. From the table, that table shows the students' marks in an exam. He wants the number of students who sat for the exam. How am I going to know this? If I have marks and 3 students scored a mark and 7 scored other mark and so on, then the sum of those students will be definitely the total number of students. By adding the frequencies, I will get the number of students. He wants the model class interval. We all know that the model class interval is the interval that have the highest frequency. And from the table, it's clear that the 20 and less than 30 is the model class interval. How many failures are there if the passing mark is 20 marks? From the table also, the students from 0 and less than 10 was 3, and the students from 0 and 10, sorry, and less than 20 was 8, and then the sum of them is equal 11. The center of the last interval was 30 and less than 40. You add the 30 plus the 40 and divide them. We know the center means the mark in the middle, which is 35, after adding 30 plus 40. All I want to say about this, that we call this the frequency polygon, and we talked about this before. It was the relation, the frequency polygon is actually a relation between the center of the interval with the frequency. We want you to know this. We call this graph histogram. Also, what I want you to know about this, that this is histogram. The one before is the frequency polygon, and then the first one was the frequency distribution table. Here is the chapter 5, the Cartesian plane and the simultaneous equations. We call this the Cartesian plane, and this is the origin point. Coordinates are 0 and 0. This is the x-axis, and then the y-axis. Positive x's, y-axis, and then up are positive y's, down are negative. Okay. He wants me first to plot the ordered pair B, the point B, 2 and negative 3. 2 is the x coordinate, negative 3 is the y coordinate. So 2 here, negative 3 is here, then the point is definitely here. Number 2, he wants me to write the coordinates of point A. It's clear that point A lies on the x-axis. That means the y-coordinate will be 0, and it is actually 2 and 0. Okay. Complete. The point negative 7 and negative 3 lies on the dash quarter. Here is negative 3, and here is negative 7, so it's in the third quarter. If you don't have, sometimes he don't provide the Cartesian plane. If you don't have it to think about the quarter, draw a small Cartesian plane aside, and that will help you to find the quarters. Also in the Cartesian plane, the coordinates of the origin point, we talked about this before, is 0 and 0. The point 2 and negative 2, sorry, lies on the dash quarter. Here is 2 and negative down, then the point is here, and this is actually the fourth quarter. We all know that this is first, second, third, and fourth. We go anti-clockwise. In the quarters, we go anti-clockwise. طيب, where the point, negative 5 and 0, lies on dash axis. We also know that if the y-coordinate is equal 0, then the point lies on the x-axis. If the x-coordinate, sorry, is 0, then it's in the y-axis. Here is the simultaneous equations. He wants me to solve those two equations. Why do we call them simultaneous equations? They are first-degree equations with two variables. He usually, to solve them, means if he asks me to solve them, that means he wants me to find the values of x and y. And because I have two variables, then he has to give me two equations. Usually, we cancel one, or we get rid of one of the variables, find the other variable's value, and then substitute to find the one that I already canceled before. So, and to cancel them, we need to make the coefficients equal. It's clear that I'll do that on the board. Let's explain that on the board. So if I have 3x minus y equals 3, 5x plus 2y equals 16. There's a mistake here. So I have to multiply equation 1 times 2. Why we do that? Because I want to make the coefficients equal, to make them both 2, but my condition is to multiply the whole equation. So that will be 6x minus 2y equals 6. And then we write down the first equation as it is, and then I want to cancel them, then I need to add both equations. So 6x plus 5x actually equals 11x. Negative 2y plus 2y, that went to 0. And then 6 plus 16, that equals 22. And then here is the value of 11x. Hence, I want 1x, then I have to divide both sides by 11, and then x will be definitely equal to 2. This is my first value. Then to get the value of the second variable, I must substitute in one of those two equations. And I think it's easier to substitute in equation 2, because the y is positive here. Okay. Substitute means you take the value. You take the x, put its value instead. So 5 times 2 plus 2y equals 16. 5 times 2, 10, plus 2y equals 16. Then you take the positive 10 to the other side, and then 2y will be equal to 16 minus 10, and then then 2y equals 6. To get the y, divide by the 2 in both sides, then the y will be equal 3 definitely. What's really important in this, if I want to write the solution set, hence they are both x, value of x, and x, a value of x and a value of y, then I have to write them in an ordered pair and also between the brackets of the set. And I must write the x first, which is 2, and then the y. Always the first one is x and the second one is the y. I think this is the end of our lesson. Inshallah, we will be continue in my second part. We will talk about the geometry in general and second degree algebraic expressions. Revise your theorems properly to be able to work with me, inshallah.